This is my newly installed QO load center that I put in for the 12 volt distribution side of the emergency power system. Just a typical 6-way 12 volt load center, and this is 12 volts, which is why I'm reaching in here where this mains don't, because each of these lugs would be at about 120 volts root mean square above ground, 240 volt root mean square between them. So don't do this. But this is running off of the master bus bars, pair of big 8 gauge cables. That's what the orange one is. The white ones are the neutral. And the two bars are wired in parallel since, are wired together since they are both 12 volts. And what I did is spliced each wire together and soldered it, and then ran that bit inside, and the screw terminal is actually clamped down on the soldered joint, so it's really securely heavily in there. And then the neutral set was just soldering the two wires together and running them to the same master bonding screw. And this is all QO, which is all good for 12 volts. It's actually good for up to 65 volts. Mine's a 12 volt nominal system, so that is not going to be a problem. And right now there's only 2 circuits installed. This one, which is this black, like SPT cable, but it's only good for up to 150 volts. But it's commonly used for 12 volt landscape lighting. That goes out to a cigarette lighter receptacle on the front porch. And that's this 15 ampere breaker, and this 15 ampere breaker is connected to this little cigarette lighter receptacle, which is mounted in the bottom of the box, because one of these cigarette lighter receptacles will fit in a half-inch conduit knockout. And then I've got a couple more strain reliefs that are installed for cables that have yet to be put in, because I'm going to be tying in more circuits to this. Probably at least another dedicated receptacle circuit upstairs, which hasn't been installed yet. And then I've got a big 30 ampere breaker, which is probably going to go and feed a master sub panel, because I've got a bunch of these German made, although some of the older ones are made in West Germany, Allen Bradley breakers. These are also all DC rated to 65 volts. But these are sizes that you can't get normal breakers in. Like, these are all 1 ampere, 2 ampere, 3 ampere, 4 ampere, 5 ampere, and this last one's a 10 ampere breaker. So what I'm going to be doing is getting some DIN rail stock, because these are all DIN rail mount breakers, from a neighbor who probably has some, because he does all kinds of weird electrical work. And mounting that here, and then building a little cabinet for those, and having a little sub panel for all the smaller lighting circuits, like that 1 ampere one's just going to be for a night light circuit for small incandescent lamps or LEDs or something like that. And then I've got other things like some small mixed lighting and small 12 volt receptacle circuits also around the house, so that's what those are going to be used for. But all that's going to run off the 30 ampere breaker, although that I just put in here to get it out of the way and reduce the chance of it getting just damaged from floating around and not doing anything. So that's pretty much it. And also, because it's 12 volt, you want to use nice thick heavy cable, because you want to minimize potential losses as much as is feasibly possible. Although I have heard some things where the skin effect and stuff, and that only happens at AC. That's only with AC, and that's only with, at 60 cycles per second, conductors with radii in excess of 1/3 of an inch. So, unless your cables are 2/3 of an inch in diameter or more, and you're dealing with AC, that isn't going to be an issue. So, that's just one little tidbit. And because it's solar, to maximize efficiencies, you want to have as little potential loss. And because it's 12 volt, you don't have that much anywhere near the overhead that you've got from mains. So yeah, that's pretty much it. And that knockout, that unless I use it, probably just going to get a plug for it, because this is still a work in progress.